Hi guys, welcome to Practical Session 8. Today we're going to be looking at spatial databases. So we're going to be introducing PostGIS, and we'll be looking at making some simple spatial database tables to represent some simple spatial structures here. So we're going to be introducing just some of the basic concepts of spatial databases. We'll be looking at the geometry data type, which is how we represent spatial items in our databases, and we'll have a quick introduction to some spatial queries and some very simple exercises for you. Today's prac is more of a tour than an actual exercise, so there's only some really straightforward stuff for you to do right at the end of the practical. So first of all, a spatial database or geodatabase is a database that's optimized to store and query data that represents basically real-world spatial objects. So some examples of that include things like roads and railways, and these can be represented by line objects. Buildings and land parcels, so cadastral maps, can be represented by polygons. Weather stations or points of interest, peak points, for example, can be represented by point objects. So if we look at those basic geometric shapes, we can represent most real-world things in a very meaningful way. Now, spatial databases allow for the implementation of a wide range of applications that contain spatial data. So if we think about applications such as Google Maps or GPS guidance applications, so the Navman type devices that you find in cars, these all make use of spatial databases to populate and actually draw their information from. So the PostGIS database extension, which is what we're going to be working with today, provides the geometry data type along with a suite of functions within the PostgreSQL database management system for implementing spatial database tables and actually building database queries based around those. So there's a whole heap of functions that you can look at for actually looking at the relationships representing and looking at the relationships between spatial objects. So for today's practical, you'll be using the pre-built database PRAC08. So this database has already been created for you with the database extensions enabled. And the reason that we've done that is because enabling PostGIS actually requires you to have administrator access on your account, which of course you don't have. So we've enabled a single database for all of the users in the course to access. So because you'll be sharing that database with other users, when you create your tables, you should do so by actually by prefixing it with your username as well. So these are just the lists, the initial lists of tables that are in there, and someone's already beat me to this one. But when you create your tables, prefix them with your username, just so that you're not treading on each other's toes with names in that system. So you're going to be just simply logging in, so PSQL PRAC08 will get you started off, and you'll have access to all of the PostGIS functions and the geometry data type to complete today's exercise. So to start off with, we're going to have a quick look at the geometry data type. The geometry data type extends the existing data model in Postgres by allowing you to create geometry valued attributes or columns within your database table. So a geometry data type can be used to represent points, lines, polygons, or multi-polygons. We can generate a simple table with a geometry valued column just by simply specifying a name using the geometry type. And in this example, we're actually specifying that it contains only lines. So we're specifying a default value here. So this database contains so the next example creates a table called roads with a geometry valued attribute called geom. So this is typically the example that you'll follow. So if we do a select from, if we select everything, from roads, we'll find very quickly that we have all of our column names. So you can see here we've got our road name, our test road, etc. If I make that a little bit wider, we can see there We've actually got our geometry object, which is actually represented by binary data in our roads table, and we've got our name and our ID. So you can see that intuitively this all fits together quite well with our database. So basically we're creating columns in our tables that represent these geometric objects. Now, once we've actually created our spatial table, we want to actually insert some data into that so we can populate it with some spatial data. And we can do this by making use of the well-known text representation for our geometric objects. Now, if we quickly jump to the PostGIS documentation, you can see here there is an entire list of functions, specifically the geometry constructors, what we're interested in, because these are used to actually create our actual geometry objects. Now, we're actually particularly interested in creating lines. So if we have a look at our ST line from text, basically we can use this to create a line from the text representation. So the well-known representation, well-known text representation is actually this part here where we're specifying, we use the keyword line string, and then we actually specify a series of points, and we make sure that we single quote that, and that will actually create our line. So if we go back to our practical session here, you can see here we're actually using this constructor to insert some line strings into our database. So immediately we can see that we're using this function in our insert statement. So if our insert statement is just a normal insert statement, so inserting into roads, we're inserting our ID value, our road name, and our geometry column. We then specify a value for our ID, specify a road name, and then we use the constructor to specify the geometry object. So here we're using the ST line from text geometric constructor, and we're specifying our line in the text format. Now we can, if we go back to the geometry constructors here, we can actually specify our line from other geometry objects. So we can actually specify it from a set of points. We can also specify it from a multi-point geometry. So go through and cover off on those, because there's a range of ways you can actually build up your geometries. But just in this example, we're just using the line string from line from text function here. And we saw before when we ran an example of this one, you can see here we're returning our data, and we can see that we've got some binary data in here. So that really isn't very meaningful for you because it's all encoded in the PostGIS format. So to observe the result here, we can actually use the accessor function. So if we go back to the PostGIS documentation, here we have the geometry accessor functions, and you can see here there's a range of different things you can access about the actual geometry. You can get the number of points, the number of dimensions. We're looking actually at the end point, so we can actually select the end point of our line, we can access the start point of our line, we can access the number of points on our line. We can access all sorts of properties about our geometry functions here. So we're actually interested in the endpoint. We want to actually return the endpoint of our line, and we do so using the endpoint. So st endpoint, it takes a geometry valued object, so a geometry valued column, and it'll return our endpoint. So if we go and actually run this query here, drop that one in, and run that, you can see here that we've actually returned our endpoint. Now we can actually combine, we can use another function here, we can nest these functions together, and we can get the text representation of that point by using the st as text function. So again, that one's in our, that's actually a further up in our basic management, in our other functions here. Or is it st as text? Here we go. st as text in our geometry output. So st as text takes a geometry object and actually outputs the text. So we can go through and use this function to actually drop out the text representation of our endpoint. Now, it's important to note here that we're only grabbing the endpoint, so you can see here that we've grabbed the point 3.4 and 3.7. That's what they're the endpoints of the lines that we've inserted into this one. we can actually go back. If we edit that, we may even be able to get, oops. So you can see there we can also get the full representation of each of the lines as well. So that's how we can actually access the basic information about our geometries and actually edit and debug them. So so far we've created a simple table with a couple of line strings in there. I might actually go through and add another couple of records to that table as well while we're running through. If we go through here, I've added a duplicate there. That's okay. I'll add another one in there. So now when we go through and select from those, we can see that we've got some more records in our database ready to use there. So you can see we've got a couple of duplicates, but we've got some different ones in there as well. So so just before we move on, here's another example of grabbing the individual endpoints. Again, we've nested our functions together, and we're operating on we're grabbing the x and y coordinates alone from our endpoint. So if we run this example, you can see that we'll just get some columns with our x and y points for the endpoint of our geometry. So an important point to note here is that not all functions can work on all geometries. So if we have a look at the STY function, it only works on a point type object. So remember, we can store lines, points, polygons, and multi-polygons in our geometry columns, but some of the functions will only operate on particular types. So in this situation, the STY function will only return the y-coordinate point of a point function, and it'll return null if not available. So input must be a point for this one. Otherwise, it can't make sense of it. So just be aware of that and make sure you read the documentation for these functions carefully when you're working with them. So the final section of today's prac covers off on spatial queries. So once we've got some spatial data in our database, we can actually carry out some queries on our data. Now, the spatial queries are based around conditions that are related to the spatial properties of the geometry object or the geometry type columns. Now, we're going to build up some spatial queries using the spatial relationships functions. Now, these are basically functions provided by PostGIS that allow you to examine the relationship between different spatial objects here. So, for example, we can work out what the closest point is to another geometry. We can work out if one contains another geometry. We can work out distances. There's all sorts of functions. We can work out if they intersect, if geometries intersect. So there's all sorts of functions here that we can look at. And we can also, these work in 3 dimensions. So recall, we do actually have 3 dimensions to work in. We're only working in 2 of these at the moment. So we'll jump back in and go through some examples. So the first one is, if we want to find the distance between all geometry objects within the roads database, we can actually look at this particular query. So you can see here straight off, we're actually just printing out. We're actually selecting from the roads table twice as roads 1 and roads 2, because we've only got one geometry column, we're going to be comparing each item to every other item in the table. So we do that by adding the table twice, and then we just use this st distance function to get the different distance between R1 and R2. So if we go through and run this query, we'll see that we immediately will get a nice set of columns here that indicate the distance between them. Now, the reason we've got a 0 for some of these is because they actually share points, so the closest they actually join onto each other. Otherwise, we've got the distances between them. Notice that we've got all possible combinations. So, for example, we've got this one way, and then we've got, so these two are just the same query effectively, just the lines are the other way around, so a distance from one to the other and the distance from the second to the first and first to the second switched around, so they're effectively the same query. And that actually, we can put additional conditions to stop that, so we only get one entry for each particular direction, but we haven't put that into those ones. The other one, we can work out if there's any points in common, so we can use the st touches function. So if we run this one, we'll see that some of the lines actually share points between each other. So you can see there they all share they share points between them. And so basically, if we go through and review those ones, there's all sorts of different ways. So you can work out if if they don't spatially intersect, we can work out distances. And this allows us to carry out all sorts of spatial queries based upon those properties. So that's what we've got for today's practical for the introduction. So the exercise for you is quite simple. Your task is to construct a database table that stores the name and location of each capital city in Australia, and your database should use a point type geometry column to represent the location of each city. So you'll need to use a create table statement to construct your table with a geometry column. You'll need to construct a set of insert statements that will upload the data for each city. Jump onto wikipedia.org just to grab the latitude and longitude of each capital city. So when you're actually inserting your point data here, you'll have the latitudes and longitudes to insert. So obviously you'll have points instead of line strings, and you'll only have a single point there. So in order to do that, you'll need to go and actually look up in the geometry constructors. You'll want to create a point, so you'll be making a point from text. So where are we here? st point from text is the geometry constructor that you'll be using, and you'll want to actually grab hold of the actual the latitude and longitude for each of the capital cities. So you'll have to end up with an insert statement for each capital city using that particular function. Once you've constructed the query, once you've constructed the table, you need to create a query that finds the distance between each capital city to every other capital city. And you should do so using the st distance function. And then the second one is you should contain a query that returns all capital cities that lie within 1,000 kilometres of Melbourne. So there's a couple of exercises there. They're fairly straightforward. It's just to give you, the idea of this practice is just to give you an introduction to building spatial databases using PostGIS. So that's all we've got for today's prac, guys. Make sure you get in and complete that one.